Hello friends, welcome to engineering tutorial. So we will continue our discussion with signals and systems, the basic operations on signals. And so far we have covered various basic operations such as time shifting, time reversal, amplitude scaling, amplitude inversion, and their modified versions. So in this video we are going to discuss another signal operation which is called as time scaling. Okay, so what this time scaling operation will do? Suppose we have a signal, continuous time signal. First we'll discuss with continuous time, then discrete time. So we have a continuous time signal, reference signal xt, and we have to perform time scaling on this signal to generate a time scaled signal yt. So this time scaled signal can be of this form or it can be of this form. Any real number is multiplied with time within the bracket or divided. So this will result in two different outputs. The nature of the output will be different as compared to the original reference signal, which we will discuss in this video. Okay, so these are the two types of scaling operations that are done, and how it will affect this reference signal we will see. I will not tell it here because it will create some confusion. We will perform this two types of scaling and then we will see how it affects the reference input signal. So these are the two types of scaling that are done. Time scaling. So it is very much similar to amplitude scaling. In amplitude scaling, the scaling was done to the amplitude, that is, we created a signal like this, axt, amplitude was multiplied with a value, let us nxt, let's say, or it was done like xt by n. Okay, amplitude scaling and the amplitude. So this was amplitude scaling, this is time scaling. So now we will see how this time scaling affects this original reference signal. Okay, so now we will perform the time scaling on a reference signal and we will see how the time scaling operation changes the nature of the signal, the shape of the signal. So here we have is the reference signal xt with respect to t. This is the shape. So we will write down the values. So x0 is 0, okay, x1 it is equal to 2, x2 is equal to 2, x3 is equal to 0. Also we can add some additional points. It is, if necessary, it will be x 0.5, it is 1, and x 2.5, it is also equal to 1. Okay, we don't know whether they will come into play or not, but still let us write it down. So now we have to perform time scaling to generate a new signal yt which will be equal to, let's say x, let's take n as 2, x 2t. Okay, so now we have to determine the values of yt at different time instants, such as t equals to 0, 1, 2, 3 and all that. Okay, so let us start with t equals to 0. So y0 will be equal to x 2 to 0 equal to x0, which is equal to 0. Then y1 will be equal to x2 to 1, which will be equal to x2 equal to 2. y2 equal to x2 into 2, 2t equal to x4. So now here it is interesting. There is no x4, it is not defined. No such signal exists at t equals to 4. See, up to only 3, it lies in between 0 and 3. So this is not defined, so we will not write anything. We will take this portion out. So here is the important thing. We have to select the value of t in such a way that 2t, okay, this value 2t lies in between 0 and 3. Suppose we select t equals to 2, it will be x4, 4 is not there. So we have to select the value of t in such a way that xt will be in such a way that this 2t value will come in between 0 and 3. So now suppose, let's say we select t as 0.5, y 0.5, it will be x2 into, okay, here the dot stands for multiplication. So here, as there is already point coming, so in order to avoid confusion, I will use this 2 into 0.5, which will be x1. x1 is there, x1 is 2. So we selected the value of t in such a way that 2t lies in between 0 and 3. y 0.5. Okay, let us select y as 1.5. y 1.5 will be x2 into 1.5, which is equal to x3, which is equal to 0. So all the points are taken, 0 and 3, x 0 and 3, and all the corresponding signal points also we have got. Okay, so now, okay, x3, yes. So now we have to draw the output signal. Okay, 0, x0, x2, x1 and x3, x0, x1, x2, x3, all the signals points and distinct points are considered. So now we will write here the values of y. So y0 is equal to 0, y 0.5 is equal to 2, y1 is equal to 2, and y 1.5 is equal to 0. So again I will repeat, we have to select the value of t in such a way that this 2t value will lie in between 0 and 3, because this is the reference signal xt. So whatever this signal, this distinct point, the signal value at a particular point that we want, it has to lie in between 0 and 3. So we have to select t in such a way that this 2t, it lies in between the values 0 and 3. Any value between 0 and 3 will be okay, because the signal exists It exists between 0 and 3. It does not exist to the left or to the right. Okay, so we have got these values and we have to construct the signal, the time scaled signal, using these values. Okay, so now we will draw the signal yt. So for that we will take the time axis and the amplitude axis. 0, it will be 0, 0.5, 1 and 1.5. Here it is 1 and 2. Okay, y0 is 0, this is yt st. y0 is 0, y 0.5 is 2, y1 is 2, y 1.5 is 0. So now we'll join them. So now if you compare this yt signal, okay, this is the signal, okay, 0, y0 is 0, y 0.5 is 2, y1 is 2, y 1.5 is 0. Yt versus t, this is xt versus t. So if we compare these two signals, okay, I hope both the signals are visible. Okay, so if we compare these two signals, the shape of the signal, the general shape of the signal is intact, okay, but the time, the width in terms of the horizontal axis, the time axis, this has decreased. Here the signal existed from 0 to 3, t equals to 0 to t equals to 3, but here it is half of that because of this factor 2 multiplied with t. This has decreased the width, the time width, the time interval of the signal. Here the original signal was from 0 to 3, but here it is half of that, 0 to 1.5. So if you notice, the amplitude at each of these points in the reference signal, the same amplitude exists at half of these values. So here at 0 it was 0, so here also at 0 it is 0. Here at 1, t equals to 1, it is 2. Here at t equals to 0.5, which is 1 by 2. 0.5 is equal to 1 by 2. That value is 2 here. Here at 1, t equals to 1, the amplitude is 2. Here at t equals to 0.5, it is 2. Here at t equals to 2, the amplitude is 2. Here at t equals to 1, okay, 1, which is 2 by 2, half of that, the amplitude is 2. Here at t equals to 3, the amplitude is 0. Here at t equals to 1.5, 1.5 is 3 by 2, half of that, the amplitude is 0. So it follows the same pattern. The general shape is intact, but the width of the signal on the time axis, it has decreased. Actually it is half of the original signal. Okay, but the amplitude stays the same. There is no change in the amplitude. Only the amplitude which was there at the time instance in the reference signal, the same amplitude exists at half values of those time instants. 1, which is 0.5, 2, here it is 1, 3, here it is 3 by 2, 1.5. So notice this pattern which is emerging here. This is for x2t. Now we will discuss for xt by 2. Okay, so let us do that. So we have performed the signal time scaling operation yt equals to x2t. Now let us do the other one. Yt equals to xt by 2. Let us do this time scaling operation and let's see how it affects the signal output. Okay, again the same routine. we have to determine the values of this new signal at different time instants. So first y0, which will be equal to x0 by 2, which will be x0 is 0. So these points are very important to consider. Okay, if you are getting started with this subject, I recommend you, while doing any signal operation, please write the values of the amplitude at different time instant for the reference signal. Okay, it will help you. So y0 is this, then y1 is xt by 2, so it will be x1 by 2, which will be 0.5, x 0.5, x 0.5, see, this came into play, x 0.5 is equal to 1. y2 is equal to x2 by 2, which will be equal to x1, x1 is equal to 2. y3 is equal to x3 by 2, which is x1.5, x1.5 here, x1.5 is also 2. See, in between 1 and 2, 1.5 will be here in the middle, it is 2. So x1.5 is also 2. So y4 will be x4 by 2, which will be x2. x2 is 2. Similarly, y5 will be x5 by 2, which is x2.5. x2.5 is equal to 1. See, in between here and there, it was 1. Then y6, x6 by 2, xt by 2, y6 is x6 by 2, which is x3. x3 is 0. So we have got all the values. So here the time scaled signal, because of this operation, it has the time instants has increased from 0 to 6. Here it was from 0 to 3 in the reference signal, 0 to 3, but in the time scaled signal it has increased up to 6. Okay, in the other version x2t, the time instant decreased half of this, okay, 3 to 1.5. Here it has become double. In this operation t by 2, it has become double of the original signal, from 3 to 6, twice of this. So in the other version x2t, the time interval, it was half, 3 by 2, 1.5. In this version xt by 2, the time instant has increased 6, twice of this. So here is the pattern. So let us just draw the signal with the help of these points, y0, y1, y2, y3, y4, y5, y6. Okay, let us draw the signal, the output signal, the time scaled signal, with the help of these points. So let us first draw the time axis. It will be double as compared to the original, twice of that. The amplitude axis will be the same. So 0, 1, 2, 3, 4, 5, 6. This is the time axis. Amplitude will be the same, 1 and 2. So y0, this is yt. y0 is 0. y1 is 1. y2 is 2. y3 is 2. y4 is 2. y5 is 1. y5 is 1. Okay. And y6 is 0. So now let us join these points. Okay, so this is the signal. Now again, if we compare this time scaled signal with the original reference signal, so you can see here and here. The general shape of the signal, the pattern of the signal is the same. See, the shape is also here, this shape and this shape. It is still there, but here the width of the signal on the horizontal time axis, here it is from 0 to 3 in the reference signal, but because of this time scaling operation, here the width of the signal, the interval, the time interval of the signal on the time axis, it has increased twice the original reference signal, from 0 to 6, 2 times. In the other time scaling operation, which is x2t, the time interval became half, from 0 to 1.5, half of the original signal, 0 to 1.5. In this operation, t by 2, it increased twice of the original. So if you have to perform the time scaling operation directly without doing all these things, I mean y0, x0, y1, x 0.5 for each point, what you have to do, when it is said that you have to do something like y t equals to x nt, then what you have to do is that you will divide each of these points, okay, of the original reference signal by that factor, that number n, okay, 0 by n, 1 by n, 2 by n, 3 by n. If it is 2 here, let's say it is 2, n equals to 2. So what you have to do, you will divide each of them by 2, 0 by 2, 1 by 2, 2 by 2, 3 by 2, 1. So it will be 0, 0.5, 1, 1.5, and the amplitude for each of these points, it will be the same. Suppose I have to do here this yt equals to x2t. So what I will do, I will just replace this with their halves, that is 0, here it is 0.5, here it will be 1, be 1.5. If here I have to do x t by 2, this, I will multiply them with 2. I will multiply them by 2. Here it was originally 0, 1, 2, 3. Here I have to do x t by 2. So I will just multiply them with 2. Okay. So it will become 2, 4, 6, which is the signal here. 0, 2, 4, 6. Here it will be 1, here will be 3, here will be 5. The same thing. So this is the shortcut method. Okay, so for if you are getting started with this, I would recommend you for the first several weeks you go with this approach. When you are comfortable with this approach, you understand the whole concept, how things are working out, then you go for the shortcut method. Okay, when something is multiplied here in time scaling x nt, when n is multiplied with t in time scaling, it will be divided in this signal, the original reference signal. It will become by n by n by n. When signal is getting, n is getting divided with something in t in the time scaling operation, it will get multiplied into n at each distinct point. So we will also solve this using shortcut method. There I will explain to you how to use the shortcut method. Okay, so this is the time scaling operation, the basic concept behind the time scaling operation. So we discussed both the time scaling operations, okay, x t by n and x nt. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.